Hello everyone, welcome back to this channel. In the previous video, we have solved a problem, the fruit into baskets. Now that problem is just the longest subarray with at most two distinct values. So that was the array based problem, but at the end I have also dropped a hint for the next problem, that is longest substring with at most k distinct characters. So this is a string based problem, but the pattern behind both the problems is same. The way we have solved the previous problem, the same way we have to solve this problem as well, because previous video the problem which we were solving for, that is for the at most two distinct values, and in this video we are going to generalize that particular idea. This is the problem we are going to solve, longest substring with at most k distinct characters. Let's first read the problem statement and then we will move ahead in order to solve this problem. So this is the problem statement, and the problem statement says is that we are given with a string s and an integer k, and there is a substring which is a contiguous sequence of characters within the string, and our task is to return the length of the longest substring of s that contains at most k distinct characters, and the input we are given with is this particular string and the k value is 2. So there can be any value of 2. We have to just get to a particular logic that how we can solve any kind of problem with any value for k. So this is a problem statement, and if this problem statement feels obvious, then it is a good sign, because we have already solved this kind of problem in the last video, and that is the same pattern. This is just a generalized version of that particular problem for any value of k. So now let's move towards the logic part, that how we can solve this particular problem. And we will just cover in brief about the logic and all, and then we will directly get to the implementation, because I have already explained that how we have to solve these kind of problems. And for more explanation, I will just add inside the I button or also inside the description, and from where you can refer that particular thing. So let me just take you to the previous page where we have checked the logic of this. So first of all, we know that this particular problem is about finding the length of the longest substring with at most k distinct characters. The logic is going to be same, whether it's a array problem or it's a string problem. Okay, so let us see this. First of all, we know that the window size is not fixed in this case, as in the previous problem. So this particular problem is a part of the variable sliding window. And one thing in the sliding window problems is there that we have to check that if our window is valid or not. Means in what case our window is valid, in what case the window is invalid. So there should be distinct characters. If the distinct characters are less than equal to k, then we can say that the window is valid. Otherwise, we have to fix that. It means we have to shrink our window until it is becoming valid. And obviously, in order to count the distinct characters, and not only count the distinct characters, but also to have the check that when is a particular character is going out of the window, or when we have to remove that particular character from the window. So for that, we need a frequency map, so that it can track when a particular character it truly leaves the window. So for that purpose, we need the frequency map. And yes, the idea is going to be same, that we have to expand our window, and in case like after checking the validity, in case if that particular window is becomes invalid, then we have to shrink it from the left until it becomes valid, and if it is valid, then we have to just update the answer. So this is all about the logic of this problem, and we have just taken one example for this. This is the example we have taken, and now we are just going to perform a dry run on this. So let me just take a frequency map here. I will just name this frequency map with the name map, and for updating the answer for the maximum length, I will be just taking the max length variable, which will be initialized as 0 at the start. Okay, so first of all, what we have done is we have taken the left and right pointers, which are pointing at the 0th index, and with the help of right pointer, we will just expand the window. So firstly, the right pointer is pointing at this 0th index. So first of all, we will take this character and put it inside the frequency map. So inside the frequency map, a character comes along with the frequency count of 1. So now we have taken this particular character from here and put it inside the frequency map, and now we will check that if the window is valid or not. So first of all, we know that what is the value of k, that k value is equal to 2. It means a particular window should have at most two distinct characters. It is only having one for now. So therefore the window is valid, and we will just do that, if this window is valid, we will just take its length into consideration. So how we take the length, that is right minus left plus 1. So that is 0 minus 0 plus 1. So the maximum length for now will be 1, and then we will move this right pointer forward. Now when this right pointer moves forward, it will take this character, another character, and put it inside the frequency map. But as it is a itself, so it will just increment the count of it. So it will become 2 for now. Now it will again check for the window validity, and again the window is valid because only one character is there. Therefore the length will be updated and the length will become 2, maximum length. Then this right pointer moves ahead. and it checks for the another character, it is again a. So now the count of this a will become 3 inside the frequency map. And now we will again check for the length of this particular window, or I can say the validity. First of all, the validity of the window. So again, only one character is there, so the maximum length will now become 3. Now this right pointer again moves ahead, and it will see for another character, that is b. So now b comes inside the frequency map with its count, so that is with the count 1. And after putting inside the frequency map, we will again check for the window validity. So now we can see that the frequency map size is 2 only, means only 2 unique characters are present inside the window. So therefore the window is valid. So what we will just do is we will update the length of the window. So what will be the length? Now it will become 4. And now this right pointer moves ahead, and when this right pointer moves ahead, it again checks for a particular character, which is b, and it will update this character's frequency. So its frequency will now become 2. And again it will check for the window validity. So again the window is valid because only 2 characters are present inside the frequency map as the unique characters, so therefore the window is valid. And again it will take the length of it, so max length will now go to 5. Now this right pointer moves ahead, and it sees another character, which is b, and it will now update its frequency. So the frequency becomes 3. And now the window is again valid because only 2 characters are again present inside the window, so therefore the maximum length becomes is 6. Now this right pointer again moves ahead, and when it moves ahead, now it checks for the another character, which is our character c. So now that c character comes inside the frequency map, and that is with the count of 1. Now when the window validity is checked, so we can see that inside the frequency map the unique characters are 3, and we only want only 2 distinct characters, at most 2 distinct characters inside a particular window. But because as of now there are 3 characters, so therefore the window is not valid in this case, and now we will have to shrink this particular window. So with the help of left pointer, we will shrink this window. So first of all, left pointer is pointing at this character. So what will happen? We will go inside the frequency map, and we will remove the one of the occurrence of this particular character. So it is very important that we are removing one occurrence of the character, not all occurrences are removed. Okay, so as of now only one occurrence will be removed. So this a this 3 will be converted to 2 because one character is removed, or one character, not one occurrence of that character is removed, and then the left pointer will move forward. Now again we will check for the window validity, that is the window valid. We can see that the window is still invalid because as of now also there are 3 characters inside the window. So therefore we will again shrink this window. So now left pointer is pointing at this character, so one occurrence of this a will be removed again. So now this will become 1. And now again this left pointer will move forward, and when it moves forward, it will again check for the window validity. So again the window is still invalid because again the 3 characters are present here. So again the window will be shrinked. So therefore with the help of left pointer is pointing at this character, so one more occurrence of this character will be removed, and it will now become 0. And then this left pointer will move ahead. Now we can see here that the moment any of the characters frequency is 0 inside the frequency map, that character has to be removed. And this is again another purpose of the frequency map we are using. Why we are using. So frequency map is used so that it can not only tell the frequency of a particular character inside the window, but also that at what point a particular character has to be removed from the window. So now the character's frequency, the character A frequency is 0, so therefore it has to be removed from the frequency map. So we will just remove in this way. Okay, so this character is removed from this frequency map, and once the particular character is removed, now we will again check for the window validity. So window validity is in this case the window is valid because inside the frequency map we can see that only 2 characters, unique characters, are present inside the window. Therefore inside the window only 2 characters are present, and we also want at most 2 characters inside the window. So therefore the window is valid, and we can just take its length into consideration. So what is the length now? Right minus left plus 1, that is 6 minus 3 plus 1. 6 minus 3 3 plus 1 4. So we can see that what is maximum out of 6 and 4? 6 is the maximum, therefore as of now the maximum length is 6. So this is how we have to solve the problem, and we can just solve this problem till the end. And for the more explanation, as I have already told, I will just put it inside the I button, that video, and also in the description, so you can refer that particular video or the explanation from there. So this is the whole part of this problem, And we have just discussed the logic and a simple dry run, a small dry run here. And now let's just get into the implementation part and let's implement it, and then we will check for the time and space complexity. So this is the problem. This is the function which we have to complete. Now, first of all, what we will have to do is we will have to first take the size of this string. So that is, this is n equal to s dot size. Okay, now what we have to do is we have to just take the unordered map, frequency map here. So the two parameters will be taken. One is the character type because we are having the characters, and the second will be the integer type because we have to take the frequencies of those characters. So let's just name it as frequency map. This is a frequency map, and now what we have to do is we have to just maintain a max length variable which we will be updating, and also two pointers where the left and the right pointer pointing at the 0th index. So this is left equal to 0 and right equal to 0. Both are pointing at the 0th index. Okay, and now we will just take the while loop where this particular while loop will be running until this right pointer is less than n. Means the moment it goes at n, we have to stop in that case. Now what we have to do is we have to take every element or sorry, every character from the string, and we have to put it inside the frequency map along with its count for the frequency. So inside the frequency map, how we have to take the character, this s of this index. So s of the left pointer, sorry, the right pointer. So with the help of right pointer, we will just take that element or the character and put it inside the frequency map along with its frequency count, increment its frequency. After this, we have to check for the window validity. So when will the window become invalid? Window will become invalid when the frequency map dot size goes beyond k, because we want at most k distinct characters inside the window. Okay, for that particular substring. So the moment frequency map dot size becomes greater than k, at that point the window becomes invalid. So in that case, what we can do is we can just put a while loop here, and we can say that till the point this frequency map dot size is greater than k, we have to do something here. We have to shrink the window, and with the help of left pointer. So we can just take this frequency map. We can just take frequency map and this s of left. With the help of left pointer, we will just decrement the one of the occurrence of that character, and also we will check at the same time that if frequency map of s of left, if it is equal to 0, means if its frequency is 0, then we can just take or we can erase, we can just erase the frequency, we can just erase that character from there. So frequency map dot erase which character, that is s of left. Okay, and we can just take the left pointer and move it forward. So this is how we have to do. And once we get a particular window which is now became valid, means frequency map dot size is less than equal to k, then the window is valid and we can come out of this while loop. Now see, once we did this, what we have to do is when we have taken a particular character from the string and we have put it inside the frequency map along with its frequency count, incrementing the frequency count. After that, what we have to do, see, in both the cases, if the frequency map dot size is less than equal to k, then we know that the window is valid. Then after that, what we have to do is we have to just take the max length variable and we have to update it with the maximum length. That is whatever the previous maximum length is there and whatever is the current length will be there. That is right minus left plus 1. Okay, this we have to do, and also we have to increment this right pointer. And also in case if the window is invalid, then in that case we have to just shrink the window with the help of left pointer, and the moment it becomes valid we have to again update the length for that valid window with the maximum one. So this is again, so this particular thing has to be done in both the cases. Either the window is valid, then we can directly update the length, or if the window is invalid, then we can shrink the window till it becomes valid, and after that when it becomes valid we have to again update that particular length for the valid window. So this thing we have to do in both the cases. At the end, what we have to do is we have to just come and return here the maximum length. So now let me just take the input and then perform a run here. So input is, the string is AAA greedily, and for k equal to 2 we have to solve this. So let's just perform a run here. The output for this particular input should be 6. We have seen in the dry run. Okay, so the length of the longest substring of s, the string, that contains at most k distinct characters, means for at most two distinct characters it is 6. And let me just check for 3 as well. Let's see what comes. 8. Okay, so that is like this particular string AAA BBB CC. So this is the complete string where it is having at most 3 distinct characters. So this is all about the implementation of this particular logic. So now talking about the time and space complexity. So every character is coming inside the window and leaving the window once. So therefore the time complexity is linear in this case. Therefore O of n time complexity. Now talking about the space complexity. So in the previous problem we have solved for the specific value for two, at most two distinct values. So therefore the space complexity was constant in that case. But in this particular problem we are generalizing the case. So the k value can be any value. Therefore, for any value of k, uh, the k number of characters can be there inside the frequency map. And as we are using the frequency map, so any of the k unique values can be there. The k distinct values or the k distinct characters will be there inside the frequency map. Therefore, the space complexity will be O of k in this case. This is all about this problem. Now, for this particular problem, we have seen that how we can get the length of the longest substring with at most k distinct characters. But here we are allowing the duplicate characters as well. But what if a particular constraint is there that we are not allowing the duplicate characters, means any of the characters will not repeat. So for that kind of problem, we will be solving another problem in the next video. And till then, just keep learning, keep growing. This is Aditya Padaria signing off. Thank you.